Talk will be DevOps Bird Eyes View on Plone 6 Backend, presented by Jens Kleiner.
Yeah. Thank you for being here. I just have no slides up there. Much better. I just made the title a bit shorter. DevOps Bird's Eye View on Plone 6. Not only backend, also on front end part. It's this in terms of Plone front end. And showed by me. I'm Jens Klein, by Klein Part, located in Austria, and we welcome you here to the talk. Short overview, what we'll cover in this talk. First, a bit architecture and pip install Plone, then the very basic deployment of Plone, what you do, how you do it, and how it's composite of, and then more complex deployments you can do, how it would look like, and everything from the bird's eye perspective. So I don't go into detail how to do it or so, because we had this on Monday in the deployment training already. So if you participated there, then you can leave here. But I have some nice graphics in there, so you may want to stay. And then we can come to containerization and also talk a bit about caching. So let's see what the basic architecture of our Plone is. So in past we had only this backend and this is classic UI, and if you use classic UI you still have only the right part on the chart. And today we have the Plone front end, and both talk to each other, or at least Plone front end asks the Plone backend for data. And this is currently what we have. Then we have in Plone a database, and that consists of, if you take it by the default installation, you get ZODB, which is part of Plone in this case if you don't configure anything extra, and you have a blob storage, which is just a folder in the file system where there's a tree of all binary objects that you upload to your Plone site, so that they are not part of the ZODB. Otherwise, the ZODB would blow up and slow. We had this in past in all the Plone versions, and then we had this shiny new blob storage thingy, and then everything was faster. The Plone frontend is a simplified server that delivers JavaScript, CSS resources, and it also pre-renders the sites on the first request, and probably does more, and direct talks therefore to the Plone backend, which is important if it comes to deployment to know this. And usually the front end is something customized, so you usually customize your front end. You rarely use a vanilla Volto front end. And this front end code, there's a generator that generates scaffolding, and then you can start from there. This is very simplified how it looks like. And the backend is in Python, written in Python, is a Whiskey server. It's based on Zope 5. And it contains a complete CMS, so it's a complete REST API with everything. That's also called then headless CMS. It's scalable, horizontal scalable, and you can really serve large sites with, like Eriko told today in his talk about Plone Gulf in Brazil, which serves hundreds, thousands, millions of users with sites. And also the backend is customizable. First, through the REST API by changing settings and also changing content types and such and other settings. Or it is extensible by adding add-ons to the backend, so you don't have to write code, it's just configuration. You can add an authentication add-on for OAuth 2, and that works just by adding some configuration. Or then you can go one step further and customize this with the component architecture with Python packages. You can generate these packages again with Plone CLI. So you can go the full path on the Python side to customization as well. That's basically what the backend is, probably much more. In the backend, even if it's used for Volto, a modern Plone 6 site, then it still has all the classic UI features in there. So if you want, you can go there and go into something you have to configure something that's not available in Volto, not yet available in Volto. You need to go to the classic UI and click some configuration options, or even provide a profile there, but that's also then a customized backend at this point. In fact, the backend installs by using pip these days. Don't need build out anymore. Main reason here is that this is the official mainstream Python tool. There was a lot of criticism because of that we use our own stuff and it's difficult to learn, it's complex. Even if I like build out and like to use it, I think this is the right way to go. But there's there's shadow, right? Pip is also not perfect or does not serve our needs in all details. So I wrote this add-on mixdev, which is kind of the Mr. Developer for pip. And on tomorrow on Friday, there's a talk about mixdev. But in short, it's to override constraints and add version control system or the Git resources to our setup easily. Then what also Builder did was to generate the configuration for Zope with Plone ReCP Zope 2 instance. And it's gonna work not anymore, right? Because we don't have build out. So also I wrote a cookie cutter. This cookie cutter is a software that primarily we have templates and then generate from the templates with parameters some file system structures, like to do with the generators also for Volto in the Volto world, in the JavaScript world. And this is primarily the thing in very popular package, one of the top, I think one of the top 100 packages in the Python package index is cookie cutter, and the template for this is also called a cookie cutter. This is cookie cutter Zope instance. And that generates Zope configuration in almost any aspect, and you can really configure almost everything without editing the config file. So it can be really bit, yeah, it gets complex and it's easier to use it this way. And the backend, there's a Whiskey server, and to start Zope, you say run Whiskey with this waitress Whiskey server, but you could use a different one and give it a config file and a verbose mode maybe to get some output, and then the backend starts if you do it on your machine on command line, very basic. Then you have a front end and a back end somehow. And how does it look like then if you want to use this in a setup that you really go somehow live with it or set it into kind of very, very simple production environment where you don't have redundancy, nothing. Then you could start a Plone backend, start a Plone front end, and take a web server, like an Nginx, traffic web, what we use a lot of traffic now these days, and put it in front of both. And the web server then is responsible to get in the HTTPS request, do the TLS termination, then do the rewrite to the get the API. That's also a thing that we have now, the API. So everything that goes to the API goes to the Plone backend. Everything that is not API goes to the Plone front end. And also that's for the backends and the so-called virtual host monster rewrites. It's also a nice thing we have a monster. And you need to ensure if it's on one machine, it's not a problem, then you have a front end that talks to the backend again. So this is very basic. We don't have here a database, and this is an external database. We use a built-in database, so we can only run one backend because the database is part of this backend in this case. And probably you want to make this a bit more scalable because Plone backend is the bottleneck, usually performance-wise. So you want to spin up more than one backend. And so we need to separate the database. And here we use, for instance, the Zio server, which is the Zope enterprise object server called, which is the old, very old implementation of the Zio database, which runs on its own, and then you can start several Plone backends talking to the Zio server. But it also only stores the normal data, not the binary data. The binary data goes to the file system. The file system needs then to be shared, like an NFS or something like that, because if you then start using this because you want to have more CPUs using more servers than one machine, then it's better to have a shared file system. If you're still on one machine, everything's fine. But if you go to more machines, then it's like that. And that said, this all works on classical virtual machines, on bare metal, whatever you want. It really is just a scheme how to do this, and you can do it, yeah, with what you have in your environment. For sure, the Plone front end does not need that much computing power, so it really takes a while until you reach the point where you need to scale up the front end. The backend does more work here because it needs to query a database, compile all the data, do all the security we have in Plone, which is very handy to have all the security layers in there, but it's also very expensive on the other hand to check all the time for every request the security, and so on, and do all the calculations and the queries. And so this is more expensive than the front end, so I would say take a while until you really the front end goes up with CPU power, but even you can scale the front end as well. It's not a problem. But at some point this Zio server, it's fine, it works, but it's a special implementation of a database. Nobody outside the world of Plone and Zope knows what a Zio server is. That's often a problem if you come to a company or organization that and talk to administrators. What should I install there? A Zio? Well, tell them, give me a Postgres, give me a MySQL, give me your managed database, give me what you have. I store my data in there. Not what I have, but at least Oracle, MySQL, and Postgres works, and it's tested. And I don't have much experience with MySQL at this point. I had my bad experience in the past and didn't use it for that, but in fact it should work, and the RelStorage is called the layer, is tested against MySQL, and these days it should work, or maybe we had a bad database administrator, probably. So you can use now a relational database, and the nice thing about a relational database, at least if it comes to Postgres, I have this experience, you don't need a shared blob storage. It can take the blobs and you store it in the database and just munch it and all done. And you have one entity where your data is. And it's also faster then because if you have two databases and you have one transaction, you need to synchronize this between the file system and the database, and then a transaction takes more time just because you need to check that both data is written and then the transaction is done. And if you have one database, and like in RelStorage it's quite optimized, then the transaction is really, really short. The locking on the database, locking off everything, because it locks something for a short time. And that is also an important point here, right? So now you have all on your fingertips to build scalable fast sites. You can also replicate the database. You could use backends that use a read-only copy from the database, but we have this problem at the moment that the image scales are generated on the fly, on access time, and not on storage time. But I think we can come over this at some point. So yeah, you can now store data, have a nice fresh Volta front end, which is your own code, probably maybe a standard Plone backend, or maybe some add-ons in there, and a web server in front of it. So everything with this information, what you need, now you can write an Ansible script or Puppet or whatever you use, or just a bash script to set up your server, or type it by hand or copy it over. You can, yeah, but yeah, maybe you should use some automation and set up a server, right? That's possible. Set up a cluster, run it, update it, and so on and so on. And at some point, you have a lot of requests, right? At some point, you have a site that gets larger, and you have a site that needs some kind of caching. So you want to cache the responses from the back end and from the front end. And there are different approaches to do this. So you can just go to some cloud provider and do an insert coin there, and then magically you get a service where you can start caching your site. And yeah, that's what a lot of organizations do, and so you have a web application firewall in there and all this nice stuff. So that's good. But on the other hand, you might want to have your system in your hands and don't want the dependency. Then there's another option, and that is to use the Varnish cache in your setup, on your own machines. So you don't have a web application firewall, or even that you can do in front of this again if you like and manage this. I know organizations that do their own work on to use the web application firewall in front of this. Anyway, so if you look at this here, you see that these red circles, that the left upper one that would be the cloud-based service. It's put between the request and your web server. And then you have the one with two circles, but in fact it's one service in there that caches the responses from the front end, responses from back end. And what's important here is that the system needs to be configured to also set the right headers here, that the caching server knows what to do with this, like how long to cache or not to cache, or also what also helps is here caching for like 1 second or 3 seconds. That's also crazy, but that works on high load scenarios where you always want to have the newest data. If you cache for 3 seconds and you have a site under really high load, then it's fast. And if the site load goes down, then the site, every request goes to the backend. The site is slower under low load than under high load. That's also something that happens in there. So you need to really figure out what you want to do. And then the cache can be configured here in different ways, but it doesn't matter at this point. It's just a bird's eye view on this stuff. Okay, so short summary of the components. We have the front end, we have the back end, we have a web server or web router, and probably we need also then, I skipped this a bit, a load balancer, because somehow we need to balance the load to the different backends or different front ends. You can use their an Ajax proxy, or you can use Varnish to load balance, or you can use the traffic web server to load balance. Then we have the storage, maybe RelStorage with Postgres, or maybe also with MySQL, and some caching server. So that's our big picture now, right? That's what we have. Now, we have some hosting options. We want to do deployment, right? We want to operate this. And our hosting options, yeah, we have bare metal servers with virtual machines. We have all the nice container stuff with Docker, Docker Swarm, or Kubernetes. That's too lot for the talk, so I fix this and say I do containers and Docker Swarm here. Short disclaimer about Docker Swarm. It's not really that supported anymore, and the world moves to Kubernetes. But if you start with it, it's really good to get into all this containerization work, so it's much easier to understand than Kubernetes, because it's really a magnitude more of complexity in Kubernetes. And if you get the concepts in Swarm, you learned already the first step for Kubernetes, because then because it really it applies all. More, it's like Kubernetes is developed further from this, and in fact it's generic. So containerization. This means in containers if we have containers, that means that we have some environment like Docker Swarm or Kubernetes with a container runtime where I can start containers, stop containers, orchestrate, spin up networks in the containers, and either isolate networks from each other, and so on and so on. So what I need then is what I run in a container is an image of an application, which is in fact a stripped down operating system with this one application usually I want to run. Like the idea in a container is that you run one task, one process in there. That's it. And so I need images for the different parts we had before, the components. And they are all in place. We have the Plone backend, we have the Plone front end. That's pre-built images. We built them for the releases, and we have also nightly builds from them. And then we have the mainstream things like the PostgreSQL, like the traffic web server I use now here as an example, but you could also use something else, also Varnish. So what about custom images? As you know, as I said, you usually have to build your own front-end image, right? So because you customize Volto, and even if you can use the backend with the vanilla Plone, then it's fine. If you use the released add-ons, you can plug them in with a mechanism with environment variables and so on. Then they are downloaded when the container spins up. But if you want to really have a customized backend, then you need to build your own image for your backend too. So what takeaway here is we need somehow to build images. And usually you don't want to do this on your machine because they are large and like half a gigabyte or something like that. And if you're in the lucky situation that you have a good internet connection, all is fine, and upstream at least also that you can push this stuff. If not, then don't do this on your machine or in your office or whatever. If you're in like working on a university, like in a research organization like this, where you have like wires like this with internet connections everywhere, all fine. But otherwise, better use some centralized automation, CI/CD, continuous integration, continuous development system like GitLab CI, GitLab Actions, even Jenkins, or there are also other systems around you can choose. And then you can build there and store there the images, so it's integrated with the version control system. You push to the version control system, then maybe you set a tag, and if you set a tag as specific on the main branch, then everything starts building, right, like this. That's the idea. Yeah, and that's for the front end, for the back end images. And now we need to deploy the images in some way. In fact, if you deploy the images, you have a YAML file. Don't show this now because no code, also no YAML. But you have a YAML file, there's a specification in how my configuration is, how this works together. And then you say Docker stack deploy, that's the Docker Swarm way to deploy something, and give your name and the YAML file, and then it starts deploying your YAML file with all your settings to the Docker Swarm. That's basically how it works. You can just, even if you have your own, and you want to try this out on your machine, you could install Docker and do Docker Swarm init. Then you don't need to use Docker Compose anymore, then you can use Docker Swarm, which gives you also on your local machine some control over the resources, because with Docker, without anything, you don't have the control over the resources. With Docker Swarm, if some service gets up taking all your memory, then it takes it. With Docker Swarm, you can say, just take 2 gigabytes and then die. It's also, it helps. With Kubernetes, it would be almost the same, and you can have one swarm with one node. It doesn't make any sense as a swarm, but it makes sense in the sense of resource management. And you can add the nodes later, or can start with some several nodes. Depends on your system. Then you need to worry about storage, because you want to store data, so the container that spins up the PostgreSQL needs a persistent volume claim, which is just persistent storage, and there are different ways to get storage into it. The simplest is just to mount something from the file system into there. I don't talk here about backup and all the stuff that is out of scope. And if you use service like AWS, Google Cloud, Azure, name it, that offer a managed database, you can also take a managed database and plug your stuff in there. That means that you don't have to worry about the database. In theory, you don't have to worry. Believe that it works. And what you also need is fixed external IP for sure, or you can then use this flexible cloud IP stuff or whatever the platform you use offer if you want to use such platforms. These are the basics that you need. And then let's look at the simple deployment for one site. Like, let's say we have one virtual machine. We install their Docker, do a Docker swarm in it, and then we have a single node Docker swarm. Very simple. You can get this at some providers for like €4, and it's enough to run this, right, for months. And you don't have any redundancy and so on, but usually you can do snapshots of the file system, and something breaks, you just take a snapshot from last day or something like that. So low budget hosting of a Plone site, right? And nothing I would recommend, but you can do this. And sometimes it's enough. And what we don't have in there is a traffic web server running in there. 2 front ends and 2 back ends. 2 because if you don't want to have downtime, you can configure it that one machine has been down, restart it, and if it's up, the second container is spun down, and then this this works in a way that you don't have any downtime if you update the front end or update the back end. And this is in fact the most basic setup. This for one site, because the traffic is now the red line around this area that is like my one stack. So if I say Docker stack and list as ls, Docker stack ls is the command, then it shows me there's one stack, and in the stack, if I do a Docker stack ps name of the stack, then I see this 4 services, or now 6 others running in there. That's one stack. Now, if you have a larger server and want to host more than one Plone site with different configurations, so you can do it in a way that you have then more Docker stacks because you have one for the traffic, one for a first Plone site, and then for each other Plone site you host another stack in there. And yeah. Maybe it's easier to look at a graphic, how it could look like. That's then the different stacks with the different containers that in there. And that's all isolated. Also, the networks are isolated from each other, and the traffic and the containers share one network together. So. You made the mistake on backend twice. Oh, yeah. Shit happens. Now, imagine one is the front end. Yeah, copy-paste, sometimes shit happens. Probably I copied over to all the other slides now. So, you know, you learned, yeah. Thank you very much for noting I have here a mistake in there. Need to correct it. Yeah, here I have also several backends. But, you know, the second one is the front end. You just rewrite in your head. And this is a deployment with a Varnish in there. And with traffic and traffic routing, you can use one Varnish on stack to serve all the sites, given that the sites are almost similar from their headers they send and so on, and don't need some special handling. So the nice thing is about it, like if a request goes in and traffic gets a request, it gets into a route site, like, oh, I have this route, and pass it to Varnish. Varnish then looks, oh, do I have it in cache? No, there's nothing in my cache. Okay, Varnish sends a request, adds a header to the request, and sends it back to the traffic web server. And the traffic web server now gets a route, I have this host name and plus this header. Oh, let's get this back to backend or frontend, depending on the API or not API path. And so you can reuse very simple one Varnish to serve several sites. That's a nice takeaway from project we had, and that was not my idea, it was Gogo's idea. So but it simplifies everything with Varnish and traffic in front. So that's primarily how you can, that works the same with, almost the same with Kubernetes, I want to say, because in Kubernetes you would have then traffic probably as an ingress, and maybe it gets more complex and you have the services in between and so on, what Kubernetes all needs, but in fact this could work on Kubernetes the same. And what's missing, and I hope we get this soon from Brasilia, what I heard from Enrico, is a Helm chart for Kubernetes. Helm is also kind of system to reduce, it adds complexity to reduce the complexity to yeah, if you use it, it's a reduced complexity. If you want to write it, it's added complexity. So it's a templating system that if you want to deploy this on Kubernetes, you have like 15 or 20 files, YAML files. We can also match it in one, but it's really quite a lot of stuff. And Helm charts is like, this is how it should look like, and its parameters, and it's saying it's written in Go, and it just is Go templating that produces these charts and applies them in the Kubernetes cluster itself, like it's also a plugin for Kubernetes. So yeah, so that's how it works. And yeah, that's the Kubernetes, if you would do it with Kubernetes. But with Docker Swarm, it really works fine, and you can host this also with it. Now, at the end, a bit to the tools. First, we have traffic, and traffic comes with traffic UI, which is just a few. You can't configure there anything, also just a few on what you have. So what is your configuration, which routes are configured, which middlewares, which services. Services can be like the load balancer as a service, and middleware is this thing that rewrites from the URL or whatever you want, or you can add headers in the middleware, or the middleware can do the gzip, also zipping the response and so on. Then it's very, if something goes wrong or it doesn't work as expected, you can look at the logs, or you can just spin up, go to the browser to how you configured it anyway. It's also wrote in traffic then to get this, and you can examples. And this is how you really find what's wrong, probably. Sometimes just a typo and doesn't find something.
I think you should mention secure certificate.
Yeah, should I mention it? Okay. Traffic comes with Let's Encrypt built in, so in some way, or this, so you can use any certificate, but with Let's Encrypt, the nice thing is that it really fully transparently gets you a Let's Encrypt certificate. You have to do really nothing. You just say in the configuration that you want to use Let's Encrypt for the site, and then you start this thing up, and it gets your certificate, it stores it, it renews it, anything. So you don't need to worry about it. It does not work if you want to scale traffic. So if you want to scale traffic, like on several machines with more than one IP going in, then this doesn't work anymore. You can think you can pay for it. That's something they earn money with this size of, yeah. But with Kubernetes, there's a way, I'm probably sure that you could also make it work with Swarm. I didn't try it, to have the sidecar thingy and kind of sidecar that has a cert manager in, and then you can use a cert manager with traffic and this works. Yeah, you can do this. But it is, with Kubernetes you need to do this because in Kubernetes you always spin up many traffic ingress, but with Swarm you don't need to do it. And if you don't want to have redundancy on traffic side, you don't need it. Or you pay for it and have your Traffic Pro. Yeah. Another thing that is very, very handy is Portainer. That is an UI and management interface, and actually you can change this stuff in there, so you probably don't want to expose it to the outside. If a traffic UI is kind of public, it's like, okay, everybody knows what I host and what the IPs are, but you can get this if you from DNS and so if you want anyway. But with Portainer, it is more, it's really management interface, and you have also users there and whatever. So it's you can have many users, different roles to allow something, different stacks and whatever. So it's an UI management tool for both for Docker, Swarm, and Kubernetes. That's and it's like a bit like a Swiss knife. We have different tools in there. Can look at stuff, look at logs to restart services, inspect what's there, see what networks has been up, storages. It's really like the management that you want to have for this black box you have. Docker Swarm is kind of a black box. You can't really look into the system, and the Portainer is really a view into this black box. That's really handy. And it's here, I get some screenshots how this may look like. This is here, if you look at one stack, you get the stack details, what machines are, how they scale, and so on. Like this. Yeah, and you get many other views in the left in the menu. You see that there are different things to do. Another tool you need really to work with it is some CI/CD system. Otherwise, it gets nasty. But with GitHub Actions, we have something that you can use, and it's there. I prefer to do this stuff in my own GitLab because I like to have some stuff in my own fingertips, so like this, right? Not to give it all away to Microsoft, but well, that's how the world works today. And even you can use Jenkins, right? And the same is you need a container registry because you want to push your images somewhere, and they need then the pull from the container registry into your Swarm or Kubernetes or something like that. And there's a container registry from Docker Hub. Then there's a GitLab registry. If you run your own GitLab or even the paid version, the SaaS version has a registry, and you can also use a GitHub registry for this stuff. There's another screenshot. What is it? Ah, yeah. That's now what you can do in a GitLab. That's only for classic UI side, I think. Yeah, that is a project we did where we have a workflow running to deploy our stuff, and if you do a push on the main branch, then you get this linting and testing running, nothing more. But if you set a tag, it builds an image. And in parallel, they do security scanning of the container, which is a feature of GitLab you can use. And it deploys to latest instance. So I have different stacks, and one deploys the latest build to automatically there, and you can just go there and look what you did and how to show it to someone. Then we have a test instance, a pre-production, and a production instance. And the idea of the test instance is that you have editors that do testing and provide their test content, and they don't want to get this deleted all the time. So that's the idea why we have the separate instance. And then we have a pre-production instance, works the same. You can press there on the button, the play button, then it sets a tag, deploys to test, and the same for pre-production, deploys to pre-production. And then if I really want to have the newest production database, most recent version, I just press the play button there and sync pre-production, and then I get my production database into pre-production to restart the stack, and I can play with a production database in a safe way. And it's really great to have these possibilities. And in past, I copied stuff around with SSH and SCP and AirSync and whatever, and you can automate all this with this, and that's really great. Yeah, now I come slowly to the end. Yeah, I want to play with this. We had a training on Monday where we did this, and there's documentation, was a training documentation there, and there's also the cookie cutter, again another cookie cutter that creates a front end, a back end, and also has all the setup to use a Docker file, has Ansible scripts to spin up a Vagrant on your local box to play with this, and have you play with your local set up Docker swarm. And there were some difficulties, I think, with M1 Max, sorry. And so it was like this, but yeah, you can also use like getting some cheap virtual machine or something like that and play around there. And all this is in the training docs, and if you really want to try this out, that's a good starting point to get into this, because all is already set and you just need to go through the steps and see how it feels and works. We just don't have a container in there, so that is something you could try to install on yourself, on your own. Yeah. But that's quite easy. It's only one image you have to install, no dependency. Okay, I'm done here. Do you have questions?
Hi. Do you have any example of Varnish configuration that you are using for Plone?
I've actually I can provide you one example if you like, and put it on gist or something like that. Yeah.
We are using the same, but we are using an older version of Varnish, I think 4. And that I was wondering if you're using a newer Varnish.
Probably it's the newest Varnish, because I think I just took the latest container, the latest image from Docker Hub, and then it's the newest version.
Yeah, so if you can. And also the second question is, when you were doing the GitLab continuous deployment, are you also testing it here? So before you're doing the deployment to pre-production or something, are you also testing it on this environment, or you're just deploying it?
I just deployed, yeah. I don't
so this
test
is next step.
So that could be a step that you really then test it with a production database. Yes, that if you need this, that's possible for sure. Yeah. It's just another step that you run then the tests in the container again. Yeah.
Okay, thank you.
Thank you. Other questions? There's a question.
Yes. Thank you for your talk. In one of your slides, you have shown a simple deployment slide for one site. You said that there's nothing you would recommend, but I'm here to ask. Next one? I think. Next one? Yeah, this one. What would be the minimal requirements for a server to host all this stuff? What do you think, or what do you?
Oh yeah, it depends on the site you host there.
Yeah,
it's
a
small site.
It's a simple site. It's a
simple site. Like 2 to 4 CPUs and 4 GB should work for a small site. Maybe 4 GB. I'm actually not sure how much Plone frontend uses, but I think it doesn't use much, so it should work.
Okay, and one more question. You introduced Mixdev to try to configure the source and so, instead of using build out and Mr. Developer and so. Don't you think that this is is a way to introduce a new tool that only Plone uses, like with build out?
That's a good question.
Isn't there anything?
But it's very lightweight. It's very lightweight. In fact, you can.
I know, but.
The problem that we have in the Plone community, and I think with Plone itself, is that we have lots of dependencies, right? And so we have this. I will talk about this tomorrow. But in short, we have the Plone constraints file, which then again gets a constraints file from Zope in there, and I think there are 2 in Zope, and. So if you want to override something with pip, it's just not possible to just put in your constraints file a new version, then it fails. So you really need to download these files, then put it there and change it in the file. And then it gets nasty, right? And Mixdive really tries to solve this problem with the pip. Pip is not that giant in all places.
Yeah, I know the internals and that. I was just saying that, isn't there anything else in the Python community doing something like this?
Yeah, I did my homework and looked around, but there's nothing. No, but there are also not many projects with that many dependencies. The question is if how to auto-scale instances, and the thing is I did not auto-scale with Docker Swarm until now. I had not the use case, but with Kubernetes it's possible easily. So yeah, but with Docker I'm not sure. Maybe it's possible.
I have a question from Discord from Arki. He asked if there's documentation about configuration of Plone 6 Volto using traffic somewhere.
I know that Victor did configuration, and I think, that's a good question. I think there is. I have my own documentation and my own configuration there. No, really have to ask Victor about it because he did this recently. It's very new, and it's there. It's in the training, right? Yeah, it's in the training, and I'm pretty sure that the cookie cutter Plone starter has this already in, because Erico did this for the deployment training. We use traffic, so we have that must be in the training documentation for the deployment as well, and for the cookie cutter in the code. So if you try this cookie cutter out, then everything should be set there. Yeah. 3 questions. Back to you.
About client-side caching, so RelStorage and Zope, you can have client-side caches with both of them. Are there any experience or recommendations for using this with containers? Because you can keep them in memory, but you also could use persistent volume claims or local volumes.
Yeah, the question is, I need to repeat because you have no microphone for the audience. The question is how to deal with client with caching on the side of the database, like in Zope or RelStorage, right? And I think it's a good idea to have no kind of state in these containers and this Plone backend, so I don't do any caching there. With the RelStorage, it's in fact not really needed from my experience, so it works pretty well without any extra file system caching there. For Zope, it's favorable if you have large ZODBs to have some caching there, so you would need this to configure this in the client, I think. But as I don't use Zope, I'm probably not the right person to ask.
Yeah, thank you for your talk. Just back onto the sysrex, you had RAM, CPU, but what about disk storage?
Which one?
You were on it, the simple.
This one?
Yeah.
Oh, this one.
The simple. Just, I would assume like 20 gigs would be more than adequate for storage to start.
What?
Like 20 gigabytes to start for storage, would that be adequate?
It depends on what you want to store, yeah. But if you don't have many binary data,
right,
then 20 gigabytes is plenty.
Okay. And then I wanted to also recommend to attendees that we did a lot of work together on the documentation under install. So go visit the version 6 of Plone 6 docs, and it does go into a lot of detail and provides additional references that you've talked about.
Yeah. Mounts?
Can you go to the one with Varnish in it?
This one?
No, I guess an earlier one. Sorry.
Single.
At least, yeah, so the picture with Varnish between.
Sorry. Red circles, where are you? There are no red circles. Huh? Yeah. Anyway.
No, it was another one, but
There was a cloud, I
you
know.
can do it without.
Done. Where are you? Containerization?
Was before containers. Must before containers.
Ah, it was okay, it was this one. This one. Yeah, okay, got it.
Two varnishes in there and
No, it's one. It's meant to be one varnish, but it's like this part is cached. That was the idea. So maybe bad visualization.
would it make sense to also put varnish between the front end and the back end in this case?
Yeah, sure. That then this would be yeah.
Of the server side.
I have no idea how to configure this with the front end, but probably yeah, we can do this. Yeah, probably it just needs a RESL API server pass set, right, to go to Varnish, and then that could work. Yeah. Okay. Thank you very much. A great discussion. Yeah.